Okay guys, welcome to my YouTube channel. In this video, I will be revising with you Science Paper 1, the paper that was written in 2019 by the internal candidates. If what I'm doing is what you are interested in, please consider hitting the red subscribe button down the channel below. So without wasting much of your time, let's go straight into the video. Alright, so if you are just watching this video for the first time, I already did part 1 of the video which involved the section A of the question, and in today's video I will be covering section B of the paper. Alright, so section B here says answer all questions in this section. Write your answers in the spaces provided on the question paper. So let's go straight to the question. So question B1 reads, figure B1.1 is a graph showing how the velocity of a car changed when the driver applied the brakes upon seeing a herd of cattle crossing the road ahead. So this is the graph which is showing the change in velocity when the driver applied is the brakes upon seeing. So it is the head of cattle, the rate of decrease of the velocity with the time. So as you can see, being the same as acceleration, that means that the formula for calculating deceleration is the same as the formula for calculating acceleration. So let's go ahead and put the formula for calculating acceleration, which says acceleration, which is A, is equal to final velocity minus initial velocity divided by time. All right, so we are going to say equal to, we will now bring our graph here and then get the initial velocity and the final velocity between point A and point B. So what is the initial velocity? Initial velocity is the velocity that an object has at the beginning, and then final velocity is the velocity that the object has at the final stage or the final point of the journey. So between point A and point B, since point B is on the right side of point A, that means that point B is the final point of the journey, and then point A is the initial or the starting point of the journey. So since we are being asked to calculate deceleration, it means that during deceleration, which is between point A and point B, it means that the car had a velocity of 12 at point A, and when the driver applied the brakes and the velocity decreased, it went to point B here, and the velocity of at point B is actually 2, and the velocity at point B is final. All right, so where am I reading the velocity? From the vertical axis. So here, this point A is at actually 12, and point B, when we go to the vertical axis here, it is at point 2. So our final velocity is 2 and our initial velocity is 12. And then where are we going to get time? Time is read from the horizontal axis, and it is the time between point A and point B. So point A is here and point B is here. So the time from point A, which is at 0 here on the time axis here, and then point B here is at 5, because if this is 0, in between 2 and 0 there must be 1, 2, here also 3, 4, 5. So our time is 5. So what we are going to say is to say, now our final velocity is 2 minus initial velocity, which is 12, over our time, which will be 5. So we are going to say acceleration is equal to 2 minus 12, which will be negative 10 divided by 5. Then we are going to say acceleration is equal to negative 10 divided by 5, which will be negative 2 meters per second square. So this now becomes our deceleration. So our deceleration is negative 2 meters per second square. All right. So let's go to question B. Question B says distance moved by the car in the 10 seconds. So we need to calculate the distance moved by the car in the 10 seconds. So we'll get back to our graph later, but we need to know how to calculate distance from the graph. So distance from the graph is given by distance is equal to the area under the graph. All right. So now, how are we going to find the area under the graph? So let's go back to the graph. So as you can see, here is the graph. So since this is the graph, A, B, and then it goes to C, and then they're saying we calculate the distance moved by the car in the 10 seconds. So you see 10 seconds is somewhere here. So from 0 to 10, all this area under the graph, if we are able to calculate it, then we are able to calculate the distance covered by the car or moved by the car. So to be able to calculate the area under the graph, we are going to cut this graph into parts. So we have this part here, which will be the triangle, and this part here, which will be the rectangle. So we are going to calculate the area of the triangle plus the area of the rectangle, add them, and that will give us the total distance moved by the car. So now let's bring down the formula to see how we can calculate the area of the triangle. So we are going to say equals to the area of the triangle is given by this formula, half times base times height. So we close bracket, excuse me, then plus the area of the rectangle is length times breadth. So now we are going to substitute here. So B stands for the base. So the base of the triangle is this line here. Then H stands for the height of the triangle is this distance here. So the distance here, which is the base of the triangle, can be read from the time axis. So since this is 0, this point B here where the distance ends is 5. So our base will be 5, and then height must be read from this distance. So since this is 0, 2, then the highest is what? 12. So for us to know the distance between 2 and 12, we must say 12 minus what? 2, so that we know this one, which will be 10. So we know that here we have 5, here we have 10. Then for the length of the rectangle, we know from 0 to here, it is actually 10. So this is the length. Then the breadth can be this one, which is the width, which can be from this point 0 to this one, which is 2. So the length will be 10, then the width or breadth will be 2. So we'll substitute half times 5 times 10, close brackets, plus 10 times 2. Then when we do the multiplication here, we'll say 5 times 2, 5 times 10, which will be 50. 50 divided by 2, which will give us 25. Then here 10 times 2, which will give us 20. So we'll say plus 20. Then 25 plus 20, which will give us 45 meters. So our distance is 45 meters. Then the second question says we calculate the average speed of the car. So let's move to the next page with more distance space here. So the formula for calculating average speed of the car is average speed is equal to total distance covered divided by total time taken. So now we are going to say equals, we'll bring our graph here. So you should understand that the total distance covered here should have been the distance that the car covered during the 10 seconds of its journey. And we already calculated in question B the distance that the car moved, which was 45. Then here we are going just to get the total time the car spent in the journey, which is 10. So same 45 divided by 10 seconds. When we divide, we'll get 4.5 meters per second as the speed. All right, so guys, you have to watch this video up to the end, because I have something that I will show you, and if you are not going to watch up to the end, you are going to miss out on what I'm about to show you. Very important. And if you haven't considered subscribing, please hit that subscribe button so that you don't lose out on my next upload. All right, so let's go to the next question. So question B2 says, figure B2.1 shows a device designed to compress crushed materials for school science project. All right, so this is a device that has been designed to crush stones for the school project, or to crush materials for the school science project. All right, so what can we see in this diagram here? So we can see the hinge, which is the pivot, the turning point. We can see this one, the lever arm. Then we can see also this part here called metal support. Then we can see this one as the piston, and inside here we can see crushed materials, and we can see here a force. And if you were to analyze properly this diagram, what we can observe here is that as this force is pushed downward, so this piston goes on the material and crush them. But we can see also another force which acts opposite to this force, upwards. So now let's go to the question. So question A says, state one condition necessary for a body to be or to maintain equilibrium. So when a body is in equilibrium, it means either it has zero velocity or speed, it has no speed, or its motion is actually constant. So a vehicle can also be in equilibrium if it maintains constant velocity. Also, an object can be in equilibrium if it is resting, or if it is at rest, or it is stationary, or it is not moving. All right. So now they are asking us to state one condition necessary for a body to maintain equilibrium. So if a car is to move with constant velocity, what condition the car must attain or must have? Or if an object is to remain at rest, what condition must it have to remain at rest? So these are the conditions. So condition number one is that the sum of the clockwise moment must equal to the sum of the anticlockwise moment. Another condition which you must give is that the sum of the total forces acting on the body must equal to 0. All right, so let's go to the next question. So question B says, calculate the moment of the force, or calculate the moment of the 50 Newton force about the hinge. All right, so before you go ahead in calculating this question, you must first of all understand what a moment is. So a moment is actually the turning effect of a force, or the rotational movement of the object caused by a circular force. All right. So for example, when do we experience a moment? When you are opening the door, what happens when you push on the door? The door doesn't move in a straight direction, but it makes a circular movement. So that kind of a circular movement is what we call a moment. So when you push on the door, your force actually causes the door to move in the circular direction. So that is what we call a moment. That circular movement is what we call a moment. So now in this question, they're asking us to calculate the moment of the force, or of the 50 Newton force about the hinge, and the hinge is the turning point. So let's go back to the question. So this is the diagram here. So they are asking the moment of this force here about this hinge here. So for us to be able to answer this question correctly, we must draw what we call a free body diagram, which is going to represent this situation, ignoring other things which we don't need to include. So we'll draw this lever arm. So this is the lever arm as the straight line. Then we'll draw this hinge as the pivot here. So we have it as the pivot. Then the next thing that we are going to do is to draw the force here. So we'll draw the force here and label it as a 50 Newton. Then the other thing is to draw this force here. As you can see, there's a force here, and this force we are drawing it somewhere here, acting upward. Then what we are going to do is to label the distance between this force which is acting through this point and the second force here. So this distance is 55 centimeters, and the next is to label this distance also, which is from this point to this point, which is 10 centimeters. So what now we are going to do here now, it is now to introduce the formula for calculating the moment. So the formula for calculating the moment is given by m, which stands for the moment, is equal to force times distance. So this force is actually this force here, and this distance is actually the distance between the pivot and the point of action or the line of action of the force. So it is this distance here between the force itself and the pivot, this distance here. So in our case here, we are going to say moment is equal to, the force is actually 50 Newton. So the distance between the force and the pivot is found by adding this distance here, 10 centimeters, plus this distance here, 55 centimeters, and 55 centimeters plus 10 centimeters, it will give us what? 65 centimeters. But we should understand that the distance, when dealing with the moments, distance should always be in meters. So that 65 centimeters can be converted in meters by dividing it with 100. So when we divide 65 centimeters by 100, we'll get 0.5 meters, 0.65 meters. So we'll say our force, it will be 50 times 0.5 meters. So we'll say moment is equal to, we are going to multiply 50 Newton times 0.65 meters, which will give us 32.5 Newton meters. These are the units for moment. Don't forget to put units in your answer. So our answer will be 32.5 Newton meters. So let's move to question number C. Question number C says, calculate the upward force F which the crushed material exerts on the piston to keep the beam in equilibrium. All right, so we'll go back to our figure here. So this is actually the same beam on the lever arm. They kept on changing the language. So this is the beam on the lever arm. So they are saying you calculate the upward force, this upward force here, which we have represented it here because it is going upward. And this is the upward force that keeps, or which is exerted by the crushed stones here. So as a person pushes this down, so this pushes also the stones down so that they are crushed. But remember, by Newton's third law of motion, which says to every action force there is an equal and opposite reaction force. So to every action force, there is an equal and opposite reaction force. So as you push this one down, you make sure that this one also reacts in the opposite direction. Now we are told that if this beam is in equilibrium, which means that the force that is pushing it downward and the force that is pushing it upward, they must be equal. Now, for us to be able to calculate that force, we must apply what we call the principle of moment, which says the clockwise moment must be equal to the anti-clockwise moment, which we can represent by our formula. So we'll leave this diagram alone, since this diagram is the same as this one here written in the free body diagram way. So we'll leave it alone at the moment. So we'll say, we'll write the formula which governs the principle of moment, which will say force 1 times force times distance 1, which is going to be this same force here times this distance of the force from the pivot, must be equal to force 2, which is this force acting downward, times the distance of the force from the pivot. All right, so what we are going to do here now is, now we are going to substitute. All right, so we'll know that this F1 will be our force, so say it is going to be equal to now times distance, which is now this distance from here. So this distance is 10 centimeters. Converted into meters, would divide 10 by 100, which will be 0.1 equal to, so this force is actually this 50 times the distance, which is 65, divided by 100, which will be 0.65. So when we multiply here, we are going to have F, which is going to be equal to, we'll make F the subject of the formula. So it is going to be now 50 times 0.65, which will be 32.5, then divided by 0.1. Then when we divide 32.5 by 0.1, we are going to get 325 newtons, which means that the force acting upwards is 325 newtons. So here what you should understand is that this force causes this object to move in an anti-clockwise direction, whilst this force pointing downward causes this beam to move in the clockwise direction. Now, if the two are in equilibrium, which means the anti-clockwise moment or the reverse rotation must be equal to the clockwise moment or the forward rotation. So this is where this formula comes from. All right, so this is F and the distance. This is the motion which will cause it to go in the anti-clockwise direction, and then the force here times the distance here is the force, or it's the moment which will cause it to go in the clockwise moment. Now if it is not moving, it means these two things are actually equal. All right, so let's go to the next question. Yeah, so this is the question I wanted you to notice, that this question actually came again last year in 2021. So it came in 2019 examination for the internals, and it also came in 2021 for the examination for the same internals. So the point is, it is very, very important that before writing the exam, you revise through the papers, because you never know, some of the question may be repeated. So if you want, you may click on this video here and go to section B of the video here, and you'll be able to see this question exactly the way it came, everything which is written here, and the way the question is asked, the same way actually that question came. All right, so this is why I said watch this video until you reach the end. So this is the point I wanted you to show you, that some of the questions are actually repeated. All right, so let's go ahead and answer this question. So B3 reads, figure B3.1 shows some energy conversions in a core powered station. So this is a core powered station. We are seeing core here being put into this station. We are seeing a boiler here, turbine generator. We are seeing 70 joules wasted in friction. We are seeing cooling tower, wasted energy here, 30 joules wasted in heating, wires, transformer, then 300 joules energy, electricity. So the same question, no difference. So then the question says, how much useful electrical energy is provided by the power station? So this question was actually a free mark. So they are asking for useful energy provided. So useful energy provided is the energy that is actually being used. So when you see here, this energy is wasted, this energy is wasted. So this one is the energy going into the power station, transmitted in for use. All right, either in industries or in households. This is the useful electricity. So it's picking this value and putting it there. So let's go to the other question. So question B says, calculate how much energy is wasted from the cooling tower. So we need to know here how much energy was wasted at the cooling tower. So for you to be able to calculate this question, you must understand the principle, the principle of conservation of energy. Energy cannot be created nor be destroyed, but it can be converted from one form to the other. So energy here, which is in core, it is in chemical form, and then chemical form, and then when it comes here, it is wasted in boiler, turbine, or generator here. So it is wasted. There's a friction energy in heat form, so it goes into heat here. Also wasted the energy in cooling here, so there's energy here wasted as in things are being cooled there. Then also there's some energy here wasted in heating these cables in the transformer. So what they want is how much energy was wasted. So the energy that was put in the system must be equal to the energy that came out of the system. So we have this energy plus this energy here plus this energy plus this energy. They must give us what? 1000 joules. So we are going to come up with an equation where we are going to say wasted energy here must be given by energy input, the energy that was put in the system, minus the energy that was wasted here, which is actual energy output. So okay, we can say wasted energy is equal to energy input minus energy output. All right, so where we are going to say energy input was 1000 minus, now energy output includes even in the other wasted energy that we know, which is 70 here was wasted. What else was wasted? Which is 30 here. What else? This 300, which was actually used also. All right. So if we subtract everything from 1000, we'll get 600 joules. So this is the energy which was wasted here. So our answer is 600 joules. So let's move to the next question. So this is question C. Question C says calculate the efficiency of the power station in the production of electrical energy. So efficiency is given by this formula, which says efficiency is equal to useful output energy divided by input energy. So what is our input energy? Our input energy is energy actually which was put in the system. In this case, it is 1000. So yeah, here we say times 100%. So we'll say input energy is actually output energy, the energy that was, useful output energy, the energy which actually did the work. So what is that energy? It's actually this 300 in this diagram here, which actually did the useful work. So 300 divided by input energy is this energy which was input there, which is 1000 times 100%. So now what we are going to do is now to evaluate, which will give us now to, when we divide 300 by 1000, we'll get 0.3, then times 100%. So 0.3 times 100%, it will give us 30%. So our efficiency is 30%. So let's move to the next question, which is B4. B4 reads a figure B4.1 shows a cylinder containing a gas of volume 5 cubic centimeters at a pressure of 100 kilopascal. The piston is pushed to half the original volume at the same temperature as shown in figure B4.2. So what we are being told, guys, here is that we have this figure here showing actually a gas containing a gas. So we have this cylinder here containing a gas of volume 5 cubic centimeters. So this is the figure B 4.1, this one here. So it is for this condition. So they are saying figure B 4.1 here, this one here, is a cylinder containing a gas of volume 5 cubic centimeters at the pressure of, or at a pressure of 100 Kelvin Pascal. Okay, now they are saying the position is pushed, or the piston is pushed to half the original volume at the same temperature as shown in figure B4.2. So in this figure B4.2, now the piston has been pushed to half. That's why it is at half here. And they are saying at the same temperature. Then they are saying state Boyle's law. So this is a bit tricky. So there's a simple way of memorizing this. Boyle's law, Charles' law, Guess law, it's this. BCG, which I call B as Boyle's law, C Charles' law, G Guess law. And then another kind of memorization is this one, TPV. So how do I memorize this? Me, I like memorizing this as beautiful, cute girls of 10 T10 provinces. So B for Boyle's law, C for Charles' law, G for Guess law, then T for temperature, P for pressure, V for volume. Now, this B moves with the temperature. So, according to Boyle's law, it says that for a fixed mass of a gas at constant temperature, pressure is directly proportional to what? To volume. I mean, is inversely proportional to volume. When you increase pressure, when you increase volume, pressure decreases. When you decrease volume, pressure increases. That's the inverse. So here, I make it simple by saying, Boyle's law, when it is pointing at temperature, it means at constant temperature. So Boyle's law at constant pressure, temperature, states that pressure is inversely proportional to volume. So, and again, this one again here, it is Charles' law. So Charles' law states that for a fixed mass of a gas at constant pressure, temperature is directly proportional to volume, meaning that when you increase temperature, you also increase volume, or when you decrease temperature of molecules, you also decrease the volume of molecules. Then this one, which is Guess law, which deals with volume, constant volume, it states that for a fixed mass of a gas at constant volume, temperature is actually directly proportional to pressure. When you increase the temperature of the molecules, pressure of the molecules also increases. When you decrease the temperature of the molecules, also the pressure also decreases. Now, when you read the question here, they're saying the piston is pushed to half the original volume at the same temperature. So if you are dealing with the same temperature here, it means that the temperature is not being changed. It is the same. So temperature is constant. So which law here it is, which deals with the constant temperature, is Boyle's law. That's why they have said state Boyle's law. So they have actually helped you. So Boyle's law is given as follows. For a fixed mass of gas at constant temperature, pressure is inversely proportional to volume. So let's go to the next question. Question B says, calculate the gas pressure in the cylinder in figure B4.2. So they need you to calculate the gas pressure here. So you should apply now Boyle's law. So Boyle's law says P1 is equal to, P1 times V1 is equal to P2 times V2. So in this case, they are saying the pressure in this diagram here times the volume in this diagram, it should be equal to the pressure in this diagram times volume in this diagram. All right, so we know already that in this diagram, which is a figure B4.1, we are told volume is 5 cubic centimeters and the pressure is what? 100 kilopascal. Then we are told In diagram B4.2, we are told the piston is pushed to half the original volume at the same temperature as shown in the figure. So, which means that if this piston has been pushed to half, it means that the volume which is remaining, if it were 5, now we are remaining with 2.5 cubic centimeters. That's why they want us now to calculate the pressure. So we are going to substitute those values. So put P for pressure, which is 100, times V for volume here, which is 5, which is equal to P here, which we don't know. We are going to calculate 4, then times volume, which is 2.5. Then we are actually going to do the multiplication. 100 times 5, which will be 500, is equal to P2 times 2.5, which will give us 2.5 P2. Then we'll make P2 the subject of the formula by dividing by 2.5, also here by 2.5. So these will cancel out. Then what we are going to remain is with P here. So here we'll divide 500 by 2.5, which will give us 200. So it means that our pressure is equal to 200 kilopascal. So we'll put our 200 kilopascal there. All right. So let's move to question C. Question C says use the kinetic theory to explain why pressure increases in the cylinder as the gas volume decreases. So remember, when you decrease the volume of the container where a gas is, it means that you are bringing particles closer. So when you bring particles closer, and you know that according to the same kinetic theory, particles in a gas are in continuous random motion and they move with high speed, colliding with themselves and the walls of the container, and these collisions are actually elastic one, which means that they produce a kind of pressure or force when they hit on the walls and themselves. Now, if you bring them closer, the collision even increases, because particles, if it were taking time for them to collide with each other, now you have brought them closer. So there will be short time that will be spent to collide with each other, and that will result in pressure. So the answer is this is so because decreasing the volume reduces the volume occupied by the gas molecules, which results into increased collision between gas molecules and the wall of the container. This increase in collision increases the pressure. All right. So let's go to the next question. Question B5 reads, the human audible frequency range is 20 kilohertz, 20 hertz to 20,000 hertz, taking the speed of sound in air as 330 meters per second. 1. What is the upper limit of the human audible frequency in kilohertz? So the upper limit, the highest frequency is this one. Now they want you to give it in kilohertz. So kilo stands for 1,000. So you kill these zeros, which stands for 1,000 here. So you represent these zeros by k. So you remain with 20 k hertz. So it will be 20 kilohertz. All right. So 2 says, what is the wavelength of the lower limit of the audible frequency range? So they want the wavelength. So you need to introduce the formula which says speed is equal to wavelength times frequency. Now they want wavelength, which is this. So you make it the subject of the formula by actually substituting first. V stands for velocity, speed, which is this one, equals wavelength, you don't know, times frequency, lower limit, which is this one, 20. So you say times 20. Then you make this the subject of the formula. So you say 330 is equal to this times that 20 times wavelength, then over 20. Here also over 20. Then here you kill that one, or you cancel them out, you remain with wavelength is equal to, divide 330 by 20, which will give you 16.5 meters as your answer. So meaning the wavelength is equal to 16.5 meters there. So let's move to the next question B. B says figure B5.1 is a diagram of a wave traveling through air. So this is the diagram of a wave traveling through air, which labeled distance represents one wavelength. So it is W. Wavelength is defined as the distance between two consecutive crests. So these here highest points of the wave, we call them crests, and the distance between the neighboring crests is what we call wavelength. So it is actually W. Then the same which labeled distance represents the amplitude of the wave. So the amplitude of the wave is the maximum distance of the wave from the equilibrium. So this line represents the equilibrium to either the highest point, which is the crest, or the trough, the lowest point, which is the trough. So the distance from here to here, it is called amplitude, or from here to here. So which letter represents that? It is actually X. So let's go to the next question. B6. B6 reads, figure B6.1 is a diagram showing the appearance of a coin immersed in water. So figure B6.1 is a diagram showing the appearance of a coin immersed in water viewed from above. So a coin immersed in water, when viewed by the eye here, if this is the coin, then it is seen to appear as if it is at this position. All right. Then the first question states, or says, state Snell's law. So this is Snell's law. It says the ratio of the real depth to the apparent depth is constant. All right, that is the Snell's law. So let's go to the next question. So B says, what happens to the rays of light at the surface of water in figure B6.1 above? So let's go to the same figure. So this is our figure. So when the ray here, when it reaches the surface of the water, it diverges away from the normal. And then this, when it is extrapolated backward, the eye sees as if the ray is moving straight like that, and as if it is moving from this point. And this is what causes this to appear as if it is here. So we can say the rays of light bends away from the normal. All right, so let's go to C. C says calculate the refractive index of water. All right, so refractive index of water from this diagram is given by this symbol. Refractive index is given by real depth divided by apparent depth. So real depth is the distance of the coin, or the real coin, yes, from the surface of the water to where the coin is, and the apparent depth is the distance from where the coin appears to be when observed by the eye. So that distance from the point where the coin appears to be to the surface of the water, which is actually 11. All right. So here we are going to say real depth is equal to this value here, 15 centimeters divided by 11.28 centimeters. So these units will cancel. So we'll have the answer as 1.33. So refractive index does not have a unit or units, because these units cancel out. So our answer is 1.33. So let's go to the next question. Question B7 reads, figure B7.1 is a circuit diagram with two resistors connected to a 3-volt power supply. So we have this circuit diagram here with these two resistors connected to what? A 3-volt power supply, and this is the switch, this is an ammeter. Then they are saying A, identify the type of circuit arrangement of the resistors shown in the circuit above. So we identify the arrangement of these resistors. What is this arrangement called? When resistors are joined end to end like this, what is this type of connection called? So this type of connection is called series arrangement. All right. So B, they are saying calculate the total resistance in the circuit. So we need to add this and this together, because since they are in a series, we just add them the way we add normal numbers. So we'll just say total resistance is equal to resistor 1 plus this one we'll call it resistor 2. Then we'll say is equal to resistor 1 is 2 plus resistor 2 is also 2 ohms. Then this will give us 4 ohms. So our answer is 4 ohms. So this is our total resistance. So let's go to the next question. C says calculate the ammeter reading when the switch is closed. So let's bring back our question here. So they need us to calculate the ammeter reading here when this switch is closed. So what will happen when the switch is closed? Current will flow here. So what will the ammeter read here? So we have to calculate then current by using this formula, which connects the voltage, resistance, and the current, which will be voltage is equal to current times resistance. So we know voltage is what? 3. So we'll make I the subject of the formula. So voltage is 3 here. Substitute it there is equal to current, we don't know, times resistor. We have already found the total resistor, which is 4. Then we'll make I the subject of the formula. So we'll say is equal to 3 I times 4, which will be 4I. Then we'll say divided by 4. Divided by 4, we'll cancel 4 into 4, it will go, will remain with I. Then 3 divided by 4, it will be 0.75. So this will be the current that will be read by the ammeter, 0.75. So B8 says a cell phone charger has a transformer with 2,000 turns in the primary coil, which converts 240 volts AC to 6 volts AC, and a rectifier that converts 6 volt AC to 6 volt DC. So question A says, what do the letters AC and DC stand for? So AC stands for alternating current, then DC stands for direct current. So let's go to the next question. B says, how many turns are in the secondary coil of the transformer? So let's bring back our question. So for us to be able to calculate the number of turns in the secondary transformer, we must be able to know the transformer equation, which says the volume in the primary coil, this V stands for volume, P stands for primary coil, divided by volume in the secondary coil is equal to a number of turns in the primary coil divided by volume, number of turns in the secondary coil. All right. So now the question says, how many turns are in the secondary coil of the transformer? So this stands for secondary coil, number of turns. So we will go to the question. A cell phone charger has a transformer with 200 turns in the primary coil. So we have 200 turns in the primary coil. So this number of turns in the primary coil will be 200, which converts 240. So meaning in the primary coil there's 240 converted to 6 volts. So here the voltage also is 240 to 6 volt, and the rectifier that converts 600 6 volt AC to 6 volt DC. So this voltage here, because this voltage is converted to this, so this voltage also it's for the secondary. So now what we are going is to substitute. That's what we are going to do. So we'll say voltage in the primary, which is 240, divided by voltage in the secondary, which is 6, is equal to number of turns in the primary, which is 2000, divided by number of turns in the secondary coil, which we don't know. So now we are going to cross multiply. So we'll say 240 times number of turns in the secondary coil, which will be 240 times ns, which is equal to 6 times 2000, which will give us 1002, 12,000. Then what we are going to do is to make sure that we make this the subject of the formula. So we'll rewrite it here as equal to the same. So same divided by 240, even here 240. So 240 goes will remain with ns is equal to, so 12,000 divided by 240 will get 50 turns. So the number of turns in the secondary coil is 50 turns. So C says draw a labeled diagram, draw a labeled diagram of a step down transformer. So this transformer here, we have already been given a leakage that it is the step down transformer, because the number of turns in the secondary coil are less than the number of turns in the primary coil. So let's draw the transformer. So we'll begin with this diagram here. Then we'll have the coil, more coil in the primary coil here. So these are coils, and then less coil in the secondary coil here. So we'll call this one the primary coil, then we'll call this one the secondary coil, then we'll call this one the ion core, because this is what they said, draw a labeled diagram of a step down transformer. So we are done. Let's go to the next question. Question B9 says the symbol 398U, 33892U represents a nuclear of uranium with nucleon number 338 and proton number 92. Then A, state the meaning of nucleon number. So it is the total sum of the protons and neutrons in the nucleus of an atom. Then B, a nucleus of uranium-238 decays to form a nucleus of thorium by the emission of an alpha particle. State the 1. Proton number of an alpha particle, B. Nucleon number of an alpha particle, then 3. Proton number of thorium, then 4. Nucleon number of thorium isotope. So what you should know is that when this one decay by alpha particle, actually an alpha particle is a helium nucleus. So a helium nucleus consists of 4 mass number and 2 proton number. So here our answer will be 2 proton number. Then they are saying nucleon number of an alpha particle. So it will be 4 here. Then proton number of thorium. So thorium, what will happen? Proton number. So what we are going to do is 92 minus actually 2 here, it will be 90. Then the nucleon number of thorium will be this 238 minus 4, which will be 234. All right. So if you are not clear on how I've answered this one, there are other videos that you can watch that I have explained how these behaviors operate. All right. So let's go to the next question, which is actually in section C. So, all right, we have come to the end of the video. We are going to continue with section C in the next video. So if you have enjoyed this video, please give it a like, and if you haven't yet subscribed, please consider subscribing so that you don't lose out on the next video. So guys, as for now, bye and please peace.